Hello everyone and welcome back to this new video of Agentic AI series. Today we are moving towards Agentic AI safety and governance, which is a fundamental boundary in AI. For years we built systems that responded to our needs. Now we are building systems that act, decide, remember, and evolve. This is not just a technological shift, as many of us think about it in the first place, but it is mostly systems and governance shift. And because here the core question is no longer is this output safe, it becomes can we trust this system over time? This topic is very important and crucial for designing AI systems. Let's first ground this transition technically. Traditional AI systems are stateless or weakly stateful. They are mostly deterministic in structure. They are single step execution. While agentic systems introduce persistent memory, multi step planning, tool orchestration, feedback loops, and so on. This creates a closed loop systems. For example, an agent observes, decides, acts, updates its internal states, and then repeats. This loops is actually where both intelligence and risk together emerge. With the emergence of behavior, intelligence, and risk, the risk surface expands. So first, let's decompose this new risk landscape. We have temporal risks. In agentic systems, errors are not isolated, they compound. A flawed assumption early in a plan can cascade into increasingly incorrect actions. Second, we have tool mediated risks. An agent can execute transactions, modify systems, trigger workflows, etc. And while this is a direct bridge between AI and real world consequences, the risks here compounds and expands more and more. Third, we have emergent risks because in multi agent systems, behavior is not programmed. It emerges from interactions between agents, and then risks as well emerges from those interactions. And finally, we have alignment drift and alignment risks because agents optimize for goals, and goals are in agent perspective are approximations. So over time, systems and agentic systems may drift from the initial human intent that was given to them. This forces a conceptual upgrade. Safety was historically output filtering, harm detection, response moderation, etc. But governance is broader. It includes behavioral control, continuous monitoring, policy enforcement, accountability mechanisms, etc. This is the difference between validating outputs and controlling systems. This leads us to responsibilities that should be introduced across all of the layers of the agentic system. So, for example, we have the model that generates text, reasoning, and predictions, is the orchestrator that plans tasks, sequences, actions, and so on. The tools and tool interaction with the that execute real-world operation, memory systems that stores context and influences future decision through the retrieval as well. Human interface defines oversight and interventions from human. Each of these layers introduce independent and interacting risks. So responsibility here should be seen and should be designed actually in a layered way, in a traceable way, and system-wide to ensure that the whole system is reliable and safe. Here is the key systematic issue. Agentic systems fail non-locally. Consider this pipeline, for example. The planner generates a flawed strategy. There's an issue in the plan that the planner generates. Then the tool executes perfectly. The system produces a harmful outcome. The no component is broken in isolation, but the systems in general fails. This is why traditional debugging fails if we look at it component by component. And why this is why governance must operate at interaction level, not at component level in isolation. This is why responsibility should be designed for in agentic systems. To govern such systems, we need decision traceability. And this means logging inputs, prompt versions, model responses, intermediate reasonings, tool calls, final outputs, and all of these intermediate actions within the system. But more importantly, we need casual traceability, and we need decision provenance. We need to answer the question: why did the system do this? And while answering that question, this transform logging into behavioral observability infrastructure instead of component observability. And because we have to design for responsibility, ethics should become operational. Historically, ethics existed as guidelines, policies, principles, but in agentic systems, we need to enforce ethics in runtime. We need to have constraint-based execution, because ethics must be embedded in planning, in action, in memory. Otherwise, they will be bypassed. This is really crucial component here, or cornerstone that we need to design our agentic systems for, to have ethics by design. Let's take a deeper look on the core ethical dimensions that we should consider in agentic systems. Alignment. Agents optimize objectives, but objectives are proxies. Misalignment emerges from when optimization diverges from original intent. Second, autonomy. How much decision power does the agent have? Autonomy must be scoped and bounded in agentic systems. Third, fairness. Bias doesn't just appear in output, it appears in decisions, in planning path, in resource allocation, etc. Fourth, accountability. Can decisions be explained, audited, and attributed? Fifth, privacy. Memory introduces persistent data risks. This is not just data leakage, it's a long-term exposure in the system. So these elements, alignment, autonomy, fairness, accountability, privacy, we should consider when we design for ethics in our agentic systems. This means ethics should be transferred from being theory to be executable. For example, a financial agent cannot execute transactions above a certain threshold. A healthcare agent must validate sources. A data agent cannot persist personally identifiable data and or information. This should be implemented through policy engines, rule-based validations, constraint-aware planning, and so on. So ethics should not be advisory in agentic system. They should be enforced logic. Guardrails are system level constraints on behavior. They operationalize safety. They are continuous, multi-layered, and context-aware. They operate across input, planning, execution, output, and memory. They define the safe operating boundary of the agent. Input guardrails. Input is the attack surface, and risks here include prompt injection, instruction hijacking, malicious intent, etc. And guardrails must detect adversarial patterns, sanitize inputs, and reject unsafe instructions, because compromised input leads to compromised behavior over time. Planning is the most critical layer. This is where intent become action sequences. Guardrail here, constrain reasoning paths, enforce policy compliance, and reject unsafe strategies. This is where, or probably the last point, where we can prevent harm before it materializes. We know execution is the interface between AI and the real world and the reality. And here, guardrails should include API permissions, rule-based access control, sandboxing environments, etc. The guiding principle for us here should be least privilege. and agents should know or should only have access to what they really absolutely need, nothing extra. Output guardrails are mostly familiar, but they are still critical. They filter unsafe responses, they validate compliance, they detect anomalies. But keep in mind that this is the final checkpoint that we have before the agentic system impact becomes full reality. Usually in agentic design, memory is a little bit under discussed, but it is one of the most critical parts. Risks here include sensitive data persistence, memory poisoning, long-term behavioral drift, etc. And guardrails must validate writes. What is the strategy to write to back to the memory, filter sensitive data, and version the memory. And on top of that, how we retrieve from the memory, because memory defines the future behavior trajectories. That's why we should keep memory guardrails at the core, at the heart of our agentic design. This leads us to a key principle: defense in depth. No single guardrail is sufficient by itself or on its own. We need redundant checks, we need layered enforcement, we need context aware policies, because safety must be continuous and not discrete. And because we cannot control the whole agentic behavior, because the behavior is emergent, we still need human in the loop. Because humans provide what AI lacks in general, like judgment, context, ethical reasoning, etc. And the human in the loop system insert the humans into decision loops, enable oversight, and provide intervention points into the agentic design, especially critical for high risk decisions or novel scenarios. There are three levels of a human control in agentic systems. We have human in the loop, which provides explicit approval, human over the loop, which is monitoring with intervention when needed, and then we have fully autonomous agents, where we have no intervention but just traces. Uh, this is a design decision, and it defines the trust boundary between human and the agentic system. There are several patterns for human in the loop designs. We have, for example, approval workflows, confidence thresholds, interrupt mechanisms, real-time dashboards, etc. The challenge is balancing three dimensions, which are the speed of the system, the scalability of the system, and the safety of the system. We should keep this trade-off in balance when we design our system. Observability here must evolve and to move from traditional system metrics like latency, errors, etc., to more cognitive metrics like decision quality, planning efficiency, behavioral consistency, and so on. This is an important shift, because here we will be starting seeing and monitoring syncing systems, and that visibility on the system will enable better governance. Such governance should introduce controlling behavior over time through audit trails, policy enforcement, continuous evaluation, compliance validation, and so on. And this should be introduced in production and as an ongoing process, and not be an offline evaluation process. While we think about governance, safety, responsibility by design in agentic systems or in single agent environment, this could be done. Multi-agent system introduce a higher level of complexity. The interaction between agent is more complex, coordination dynamics between agent as well, the emergent behavior from those interactions. And here we can see systems collaborating, competing, interfering, and so on. So safety, governance, and Guardrails should be scaled here from system level to system of the systems level. So we will have a meta system governance in such situations. And here, mitigation strategies will be introduced, such as role based agent constraints, communication protocols, oversight agents, simulation environments, etc. And we need to test the full ecosystem uh, as a whole, not only each of its components as single agents and so on. With all of those risks in agentic systems, knowing the complications of the agentic safety, responsibility, and governance, we need to keep in mind some design principles for safety. And those design principles should be engineered actually when we work on them. And some of them, like defense in depth, least privilege, fail safe defaults, explicit constraints, continuous evaluation, etc. And this will introduce safety and responsibility in agentic systems as an architectural property of the system rather than an overall layer that comes on top of the system. So far, we have seen how we govern agents today as humans designing governance systems of agentic systems. But governance itself is becoming agentic as well. First, we start to see self monitoring agents where systems will re evaluate their own decisions, detect anomalies, and flag uncertainty in real time. Second, AI auditing AI. Specialized agents will monitor others and inspect their behavior, validate compliance, and catch failures at scale. Third, we have formal verifications where we move from expectations to guarantees. Certain and safe actions become mathematically impossible. Fourth, we have policy aware models where governance is no longer external. Model will reason about rules and adapt behavior dynamically. And finally, we have some forms of decentralized governance as the ecosystem's scale control becomes more distributed across agents and systems. So, governance will not just control AI, but it will become part of how AI thinks and operates at scale. It's important at this stage to see this paradigm shift. As we move from tools to autonomous systems, we are not deploying software anymore. We are deploying autonomous systems that evolve over time. We are moving from outputs to emergent behaviors. And most importantly, we should move from safety principles only to full governance systems, uh, where the real challenge is not about capability, but it is about trust, control, and understanding. It's important to ask ourselves this question: Can we explain the decision of the system? Can we constrain the behavior? And can we govern its evolution? Agentic safety and governance is often seen as a constraint, something that slows the system down or something that slows the evolution down. But that framing is totally wrong. It's not a limitation, and it's not and cannot be an afterthought, because in agentic systems, safety is not a layer on the top. It is part of the architecture itself, as we said. It defines what the system is allowed to do, how it behaves over time, and whether it can be trusted or not, which is crucial for our systems. Agentic safety is infrastructure, is architecture. It is the foundation that makes scalable AI possible and the enabler of trust, adoption, and real world impact. Today, we have covered the principles of agentic safety and governance. And with this, we come to the end of our agentic AI engineering roadmap. And this will be the final video of our agentic AI series. And as usual, thank you for your time and attention.